So I'm going over number 4 and 6.3. Write down the matrix of the given linear transformation with respect to standard basis, domain, and codomain. So based on what was given on number 4, it's basically I can see that it's transforming each standard basis vector of the vector space of polynomials of degree 3 into a 2 by 2 matrix. So the transformation is basically transforms V to W, where V is the vector space of polynomials of degree of all polynomials of degree 3, and W represents all 2 by 2 matrices. Which is shown right here. And so since this is we're working with standard bases of the domain and codomain, it means that the basis for the domain, which is going to be 1x squared and x cubed, and then the codomain is going to be BW, which is going to be basically a sequence of 2 by 2 matrices where there's going to be a 1 in each entry and the rest are zeros. And so in the book it states that the matrix for a linear transformation is just going to be a matrix. It's going to be a matrix where each column is going to be the coordinate vector of plugging in each vector of the domain into the transformation, and each vector is going to be the coordinate vector of when you plug in each standard basis vector in the domain into the transformation, if that makes sense. So to start off, the first column, V1, is going to be when we plug in the first standard basis vector, which is going to be 1, into the transformation. So after plugging in 1 into the transformation, we get this matrix right here. And basically, since we're working with standard bases of 2 by 2 matrices, the finding the coordinate vector is going to be simple, since it's just going to be that same matrix. In this case, is going to be 1, 2, 3, and 3, which is illustrated here, because those are going to be multiples of the standard basis vectors, which is going to give you that matrix, which is shown just right. And so we repeat that same process. So the next standard basis vector is going to be x, and so we're given that plugging in x into the transformation is going to give us this matrix. And so the coordinate with respect to the standard basis vectors of 2 by 2 matrices is just going to be the same thing, the 2, 5, 6, and 8. And so the next one is going to be x squared, and we repeat that process with x cubed. And so essentially each of the coordinate vectors is going to be a column for the linear transformation matrix, and ultimately we're going to get this matrix right here. And we used both the standard basis of domain and codomain to find it.